All right, if you could please take your seats, we are ready for our next session. All right, our next session is titled Operationalizing Data Platforms. It will be led by Edgar Kraychik. He is a seasoned technology executive with an extensive background of hands-on product management and software engineering leadership, change management, technology transformation, scrappy entrepreneurship, and worldwide large-scale project deployment. He's the head of enterprise data management at Sears. Please join me in welcoming Edgar to the stage.
Good afternoon, everyone. It's a great way to spend an afternoon. Actually, I've changed the name of this slide as I was thinking about it. What am I really want to talk about? Now, my view of the world is a little bit different than most of yours. Data management is just part of the portfolio that I manage. I manage also data catalog, promotional system, pricing from the IT perspective, right, at Sears. So I'm looking at the data from the perspective from bottom up, right? I'm building a brand new data platform with Sears, trying to clean up the mess that we had and built for a long time. So as I'm taking the facts in and cleaning the data platform, I'm acting as a data plumber. At the same time, I have a number of services that we're building, accessing the intelligence, the information within the platform to build the new retail intelligence to power the digitally enhanced, digitally enriched commerce channels. So I just introduced three very different terms: data, facts, intelligence. Actually four, so information as well. Let me get the clicker here. In my presentation, I will try to cover a number of very diverse topics. I'm going to try to make it interesting for you. We'll talk about the challenges we're facing, the opportunities for the data platform, and the role that machine learning, in particular and AI in general, plays there, along with the artifacts, because it's not a unique island. It fits into overall vision. And we'll talk about elevators and some honeys and bees as well, right? So imagine yourself in April 1940. When the British intelligence services were able to crack Enigma coding machine the German military was using, the Allies could not immediately operationalize the knowledge that they had by cracking the machine. The issue was that there was a tremendous challenge. How do you take advantage of the data you have, right, to the way you communicate to the troops, how often you communicate to the troops? Do you know if your own communications are listened or not, right? And if they do, how many false positives, false negatives do you need to send, or true positives, in order not to alert the enemy that their communication is cracked? So this is a very interesting model. I think maybe some of you already have seen before, which kind of shows that in order for us to elevate from facts to intelligence, we need to go through four different steps, right? So the stuff on the left is actually our assets that we want to build, right? From facts to data to information to intelligence. And on the right, we have the actions. These actions comes with the cost and the effort. So the good analogy would be basically, as we're elevating this intelligence, as enterprise leaders, what can we do so that we're not taking the stairs, but taking an elevator, right? So if we imagine ourselves pressing those buttons, right, in order for us to go up the floor from facts to intelligence, that's what we're going to be covering today. Unfortunately, the current state within the enterprise is that it's fairly rudimentary, to the point that we actually use elevator operators. And I'm looking at some data scientists, basically, who are pressing the buttons for us. So how do we actually make the process a little bit less labor-intensive, a little bit more automated? In full accordance with the dialectic materialism that Marx put forth, maybe he stole it from Hegel, data has a quality of its own, right? So the attractiveness, right? If you imagine that these are the services that enterprise is building, right, in order to take the advantage of the intelligence, the attractiveness of the data warehouse, the data lake is obvious, right? It's the most critical, most accurate representation of the historical data, right? Given the multifacetedness, the various velocities that you have, the number of sources we have. And as an IT leader, I will tell you that we mostly focused on natural business processes and getting the data in the data lake that we're building. So we're looking at the sales, transaction, finance, supply chain, inventory movement, all of that stuff. Some of the forward-thinking IT shops are taking data from application usage of understanding, taking a better understanding what the click streams actually mean. And my personal pet peeve is that we, not only my company, but most of us, are completely deprived from the data that's taking place in the stores, right? How the customer patterns are flowing, what's the level of engagement, what's the SLAs within the stores. But even if we are taking all of that in the data lake, we're still looking at parochially based systems that give us just a subset of the world, right? So we need to extend, which actually brings a very interesting question whether IT should own data platform. In most companies that I know, IT owns the data platform. I have my own strong opinion, which is kind of controversial, but I don't think IT is the right organization to own data platform. You owning the method does not mean that you actually have an incentive to improve the data that you are collecting. And that's kind of strange coming from the IT guy. At any rate, so we need to extend. We need to take additional data from third parties, from partner data, appointments, schedule, everything, competitor action. And at the same time, there are some very good sources for us to augment data, like data cleansing, right, to introduce within data lake. Things that allow us, like create do not call list, do not promote, householding information, anything that improves the state of data within the company. Now, the data quality is one specific area where I'm really excited and really concerned as we're building data lake. There is no use to any one of the data if data are not representative, accurate of various of contextual velocity, interpreted, used, and measured, right? Those are some of the criteria that we need to have. Once we have the data in the data lake, what do we do with this? And there are two ways to go about it, right? We can interpret it in the traditional manner, build reports out of it, or we can apply artificial intelligence. And I specifically called out two methods that I'm particularly in favor of, or actually the first one, the second one I'm exploring. It's fairly kind of an old that becomes a new. So the first one is neural network, deep neural networks, that allows us to recognize the patterns, right? Deliver high order, statistical regularities within unrelated data sets. The other one is the semantic networks, which is kind of forward propagation network. Comes with their own cost. The training is very, very long, but they try to mimic the human thinking, right? The biology of human thinking, where we build synopsises forward, and it's unlike the neural networks. The third one is the human. We often overlook the role of the humans in the organization or in decision making, and I think deep neural networks without humans are not that deep yet. The whole process kind of follows a scientific discovery process, and I put just a few minutes ago pictures of Brahe, Kepler, and Newton. So we discover the data. We're basically describing them in the data lake. We're creating certain laws around them, the baseline laws, which what artificial intelligence does for us. But for deeper level observations, requires a human. That's what Newton did. So as Tychus basically described movement of the planet, Kepler has formulated the laws of the planetary movements, and Newton actually formulated the law of gravity. So the role of the humans not to be underestimated. Now, the AI is no longer a choice. It's actually in the question of whether we want to stay in a business or not. I think 99% of the creativity of the invention happens in the first two steps. There's not much creativity in capturing data, right? It's just a question of rigor. But on the second one, that's where AI comes into place. That's 99% of the improvement. There's not that many Newtons in the world, right, to make those deep observations, but we can discover quite a bit from the data themselves just by analyzing it. And the option we have, basically the choice we have, is that do we want to make implement 1,000 engineering knowledge type of rules within our data sets, or we want to experiment with the billion hypothesis, right? So there's a number of orders of magnitude difference between using AI and not using AI. I think this is a fairly obvious slide where, as human beings, we're not that good in making more than one observations or improvements. Imagine a caveman, right, creating a stone spearhead. Like from outside in, right, the first one, it would look like a work of a possessed man, right? You hit stone once, twice, 3 times, no improvement, right? It's crazy. So same thing with the fire. And that's why the process of fundamental discovery takes us so long. This is exactly where the art of AI is going to help us to cut through the unrelating data sets to discover the patterns, to help us with, excuse me, to help us cut through the random forest of all possible permutations without pursuing all of them. Now, what specifically interesting with the deep neural networks is the fact that they can help us solve the issues that are not that amenable to a human brain, right? They can help us take in the entropy of the chaotic problem and reduce it to a complex one. They can find a sufficient number high-order statistical regularities to reduce complex into complicated, and then run various clustering mechanisms, like k-means clustering, to reduce complicated into obvious, where we as humans can operate with much higher degree of comfort. Now, if we already used our machine learning models, we've cracked the information, we need to turn the information into intelligence, so data into information. So let's press the second button. The request from external system is what allows us to convert the stale information into dynamic, to convert static segments into dynamic segments, to go from segments of many to segments of one. There is a big dispute within my company, and I'm sure you have within your companies as well, and I've heard some of the discussions here, how we can predict a propensity of someone to buy or to act. I'm from the camp that I don't think it's possible without an external event, providing the context for such an interaction. I know myself pretty well. I have no idea what my interest would be this evening, for example, unless I understand the context that carries a certain payload that expresses interest in a certain categories, location, and so on. This request has to, in addition to just obvious things, obviously location, customer ID, the type of categories he or she is interested, needs to also communicate to us behavior recognition, right? If we can discern the motivation behind the request, will be good as well. That's a question not so much for ML, it's a question for the services that we're building on top of it, right? As we're building the loopback mechanism. We need to also see if we can discern the change in patterns, specific disruption that occur in the normal flow of the patterns. And also, for my Japanese friends, I use Japanese words, but basically we need to measure signal sincerity to ensure that we are not dealing, we cut out all the noise that comes with it, right? Is there interest that is true or not? Because the idea is we want to reduce the type of chatter a lot of companies engaging with the customers today, right? All the type of targeted interactions that are taking place, sending continuous number of emails that have counterproductive impact on the actual relationship that we are trying to build. So that's the difference between building a relationship or trying to maximize transactional value. I think request is one of the key, and ability to process request, one of the key things that we need to look at. Now that we are converted using a request, we understand what the context of the communication is. How do we actually connect to the sources of historical data? We need to access our analytical system, which are residing in a data management platform. Unfortunately, we cannot exit on this floor without certain changes. One of the things, a cardinal rule of IT is that operational system, and I'm much more comfortable talking about it, should not take advantage of the analytical platforms, right? There needs to be a decoupling effort because coupling is very, very expensive. And I was thinking about it, like intuitively, it doesn't make sense what I just said, right? Although many people take it as the Bible. Now, of course, it is true if you're thinking about requests as SQL queries. However, in the new world, where you can read in native SQL real-time streaming, where you can query in various formats over Parquet right from the decision support systems, that's no longer exactly true. So let's see if we actually, when we talk about operating from the perspective of data lake, right? When the analogy I was thinking about is, when I'm talking to a contractor that gives me a quote to upgrade my kitchen, he or she also already has a certain model that used by the contractor to apply to my specific circumstances. They will use a different model if I live in a condo or use in a sprawling estate, right? Same thing with the skiing instructor. There's always we as human beings, we always use pre-built models that we invoke contextually based on the interaction. So same thing with the transactional systems. We need to have access to the data lake for the reasons I already explained before. So what is it we need to do? Those are criteria that I implement in my areas that I think absolutely necessary when you look at the data management platform, the roles they're playing in the enterprise. I have a website where you can go and explore a little bit more on it. But specifically here, because of the time constraints, I don't want to go through all of it. They're pretty clear, right? Single version of truth. There has to be absolutely no ambiguity about the data. This is where I spend a lot of my time right now, trying to break through the mess and ambiguity that we have built over the years. We need to have mechanisms within the platform to expose data as a service, or intelligence as a service, I would say, which are used by data-driven workflows, at the biz that I was talking about. This is of particular concern to me, the data quality, right? I mean, data lake is nothing but a management of, storing of data, right? And but a management of metadata. So if you don't have a lineage, if you don't understand where the data coming from, you as data scientists or owners of data platform will have difficult time explaining to executives what is it you are trying to tell them. And the reason is that, as much as data scientists can tell you and explain to you the difference between RNN, GANs, and long, short-term memory RNNs, nobody knows exactly how they're working, right? So if you have garbage data, the results they're going to produce are going to be garbage. That's basically the bottom line. I would suggest, and that one of the mechanisms I'm using basically Kivia chart or spider chart, where on a weekly basis we're assessing where we are, how we're improving on all of those, I think, 8 or 9 parameters. And you may think of other ones. How well we're improving, what's the rate of improvement, right? Because that's the only way. I'm not taking a position basically as an IT leader that, I've heard a lot of you saying today, says we have to continuously work with business people. Kind of off the record, I want to build a system in competition with the business people that we have. Because my viewpoint on the services that we're building needs to be operated in math and the data. And if there's no quality data, then I have no position, right? And then I would want to argue with certain conclusions that the business is making versus what the data actually shows. So my viewpoint is I don't want to have an opinion, right? I want to have a data that I've derived and empirically from the facts that we have in the data lake. The other one, last aspect I want to bring from this slide is data governance. Huge, huge issue that until recently was a big kind of a misnomer, right, at Sears. And we're making significant progress right now to make sure that we have right data governance policies in place to ensure we prevent decay of data. Because if there is no proactive data governance, if we don't understand what continuous improvements we need to implement, the data will inevitably decay. Data is one of our best tangible assets, so we need to baby it every megabyte of data that we have. So this is a busy slide, but I think we're busy people, and I wasn't planning to build it as a technical diagram. This is more a component level diagram. What I want to bring your attention to, in my view, that's what I'm striving to build, right? Where you can see that AI plays a critical but only partial role in this view. You have your sensors, which are basically the exhaust of the transactional systems that we're using to feed into a data lake. This is our flow one. It actually reflects quite well the institutional knowledge diagram or the floors, the Appleton model floors that I've shown. On the floor above, we build our beliefs, biases, and judgments, which are mostly empowered by the AI engines that we're implementing. The big question is to which extent we need to implement them in-house and what advantages to be taking for the services available from the cloud or off the shelf. Today we have one of the huge advantages for us right now is that we have ability to stream data, to microbatch data, to run A and B analysis on the data we send from the AI engine. And once we build our data, notice I use here word dynamic. That's the nature of us actually connecting to the level 3. We can publish the data using technologies that are plethora of them, MLeap or H2O AI, which we're using on TensorFlow, as on a data model server, or on the build them as jar application within the jar, send them as jar files to include within Java applications. So if you don't want to make RPC calls to the application. So there are a plethora of things. It depends how much intelligence is included at the top level, which is actually consumer services. There are fantastic flexibilities in the way we can expose the data models. On the top, you have your standard usual suspects, reporting, business analytics users, campaigns. I want to bring your attention to a few things. Oops, sorry, I used the wrong one. Let me just, I'll play it back. Where's this thing? The field one. This is recently, and it will become a little bit more obvious what I'm talking about. As we're building, basically the nature of AI, right, is very, very different, and it's counterintuitive to software developers. Completely different. You're providing a set of inputs, and you're providing the outputs, which is the solution to the problem. You're asking, go figure out the rules, right? Which is different than what we're doing with the knowledge engineering. We're providing the rules and then the inputs, and then asking for the solution. So the field, right, investigation team is something that we probably want to deploy to confirm whether the inputs that we're feeding in our models are exhaustive. Are we missing something? Are they accurate? That's kind of a big thing for me right now to implement a team that will go and investigate proactively in the stores online to validate some of the assumptions we're making. There's also quite interesting, so the business services I'll go later in details, but basically everything we want to build to connect to the services or access agent microservices that we're building. Some of the services I'm also building, ensuring that we're continuously improving within the data platform, right? Defecting all type of discrepancy, outlier condition within data platform as they're coming from operational system, alerting the team, development team or business teams, in order for us to improve. There's also something to be said of questioning business practices, right? That's the last one, DSS, decision support systems versus humans. I don't want business to solely rely on the data or intelligence that I'm providing. I want them to have their own opinion, and then I want to basically run them in parallel and see which one is actually more accurate, right? So specifically, I need it for the training that I'm going to use to send to data scientist team to improve the models. Finishing the loop, I think some people mentioned today, obviously, the supervised deep reinforcement learning networks that we need to do to continuously improve the data sets that we have, the models that we have. So that becomes a continuous loop. The future here, this is an interesting slide because what I think is, when I looked at it, what I was thinking is, okay, well, how do we actually improve on this, right? Let's say if this is a step one. As I said, it's fairly today, in today's world, it's fairly rudimentary, it's very labor intensive. And I think there are three levels of abstraction here to be had. One level of abstraction is to expose the data model to the business users as a service. That's the DSS, decision support service, exposed through the set of microservices that are accessing our data. Second set of abstraction is for us to expose the data models to software engineers. So I don't really want to have data scientists designing a model, sending it over the bridge. What I would like to see the industry evolving to the point where software engineers can use all the libraries available from various platforms like TensorFlow, H2I, to build, train, and deploy their own models in a CI/CD manner, completely automate the process of not only deploying, but improving the data models. And I think the opportunity we're talking about here is also in the way models are going to be operated. I'm not so certain whether there is a place for data scientists as a team within an organization. I'd much rather go and buy off-the-shelf model and customize them towards my own needs, rather than have experimentational team within the company developing models from scratch. Frankly, it's a question of cost and talent and what have you. So the models that I would like to have are specific, that address specific needs, specific business issues, specific challenges for retail, whether it's a CRM question or supply chain optimization and so on. How I came about thinking about these issues. I've built some of the services, as I mentioned, I own promotional intelligence services, and I've built some of the, to eliminate the tremendous amount of manual processes. I've built a service that actually automates the promotional intelligence and decides whether we need to put an item on sale or not. And when I start looking at the map of the data, it kind of was, it didn't make any sense, because from superficially, it looked like it was completely random. When I look at the performance, let's say, this is synthetic data, but when I look at the performance of a sweater, so it sells well in Seattle, but doesn't sell well in Los Angeles. So obviously, there was not much question about it. But then I looked at around how well it sells in New York versus Florida, and I saw it's actually outsells in Florida than in New York. So go figure. So what I started thinking about, and I asked my team, is let's take a look at all the different parameters that can help us to cluster, parameterize the performance. And some of them, like basically we build a 6-dimensional inputs. I was looking at the demographics, right? Average income, children, identified location, what a location can tell us about the performance, how far is it from the city, presence of competitor, facility. As you can imagine, for us, it's a big, big issue, right? When it was updated, square footage, number of associates per floor. And obviously, one of the other things, based on my own investigation, was talking to store managers, tenure of a store manager, right? How well the store is basically run, number of associates per floor, right? And obvious ones, inventory, how deep we are in a particular categories, what's the specifically item size-wise, or how broad we are, the inventory levels, right? And then obviously promotional sales data, how often we change the price, how deep we're going in price. So all of it led to something very, very interesting. I don't have much time, but you'll have to tell me. So we build the models that tells us the key performance influencers, which data clustered around store clusters, right, by location, by various hierarchies like business unit, category, subcategory. We've exposed it to self-forecast service that was competing with the time series demand forecasting service that we used. And we exposed this data to the pricing analyst, inventory analyst. The anomalies was something like a guardrails that we built to detect any anomalies that are taking place. Like, for example, item is on the shelf but is not selling. Quite often we found was either the price hasn't changed even though they manipulate the price, just associates didn't update the price, or it's not present even though in the system it shows it's present. And we also automate the promo candidate selection process. So instead of actually running decision by Excel, the decision is now taking place from the process, from the service itself that utilizing the data we're feeding. And once it decides that the candidate is the right candidate for the promotion, it invokes another service, which we're still building, the offer intelligence. So it's a little bit aspirational. How far you're going in the promotion right now? The models are built by the prices, but we're turning it into a service. There's also micro-relocation service, which kind of looks at the clusters of 20 to 100-mile stores and tries to remanipulate the inventory levels, right? Because to address this issue, the stores within like 5-10-mile radius could drastically underperform or outperform in a certain category, certain items. I don't have time to go into product ontologies. I think this is a separate topic on itself. Let me show you some of the results, right? Those are sample results. So with the first service, we were able to say instead of like, this would be like 100% markdown or 100% optimization. You can get to much greater degrees of intelligence where you show, all right, forget about no decision, clearance 35%, right? Relocate to a better store, 10% based on the sell-through and seasonality where you are in the curve. Ship to data, DC if you're too late in the season, but there's still opportunity, the inventory levels are high, so you can probably try to resell it next year. No clearance, 20%. So basically on clearance here, you would put 30, this is markdown optimization specifically. That would be 100% clearance, right? So the 100% hit on the inventory. And some of the other decision points I want to bring your attention. This rebalancing or reallocation service works at the cluster level, the small cluster stores. Let's say in Texas, there are 4 major clusters, and the cost there is much smaller than sending them across the country. So that's kind of the minimum units that we're looking at in rebalancing the inventory. In conclusion, I want to say a couple of things. I think I'm running a little bit behind. There's not really an alternative using machine learning or AI in general. The question is whether you want to run thousands improvements or billions of improvements on the data sets. I think the next level of automation is something that we expect and strive for in the enterprise. Machine learning at scale, I really hope that the advances we are going to make will automate and productize the machine learning models that people are building so we can consume them and embed them in the services without worrying about RNN and GANs. And we can probably build some type of orchestrator that allows to apply the best model for the service, for the need that we have. And hopefully we'll build a better elevator, right? Without the operator, we just need to make sure we keep the buttons still in the elevator. Okay, I have a small video, but I think I'm out of time, right? So do you want me to wrap it up? Okay, we got it. It's a funny video. If you haven't seen it, try to find on YouTube the Scottish operator, right? Like a voice-activated elevator in Scotland. It's a riot. I only have a minute of it. So.
All right. It looks like people want the video, so if you want to play it.
Oh, well, I don't have the full video here because it gets like a little bit dirty afterwards. But the first minute, please, can you play it?
What's the buttons?
Oh no, they installed voice recognition technology in this lift. I heard about this.
Voice recognition technology in a lift in Scotland. You ever tried voice recognition technology?
No.
They don't do Scottish accents.
11.
Could you please repeat that?
11.
11. 11.
11.
Could you please repeat that?
11.
Whose idea was this? You need to try an American accent. 11. 11.
That sounds Irish, not American.
What, doesn't it? 11.
Where in America is that? Dublin?
I'm sorry. Could you please repeat that?
Try an English accent, right? 11. 11.
We for the same part of England as Dick Van Dyke.
Listen, yours then, smart ass.
Please speak slowly and clearly.
Smart ass.
11.
I'm sorry. Could you please repeat that?
All right, it goes downhill from there, so you can imagine. All right, well, that's all I have. Thank you.